Hello everyone, welcome to CAIE Science, and today we will be solving 9701 number 21 of May June 2023. Okay, so let's begin. Question number 1. Tellurium is an element in group 16. The most common isotope of tellurium is tellurium 130. So its electronic configuration is this. Complete the table 1.1. So you have to tell the nuclear number of protons and number of electrons in tellurium. So the nuclear number is actually the mass number, atomic number, and atomic number. This is your tellurium, and it has 52 proton number. The proton number of 52. Okay, so this has a proton number of 52. So the nuclear number, it's actually the mass number, and you are given this atomic mass, which is a nuclear number. So nuclear number is 1. It's actually the sum of protons and neutrons in the nucleus. Now you have 52 protons, okay, in tellurium. So if you subtract this 130 minus 52, you will get number of protons, number of neutrons. Okay, so this is 78. You have 78 neutrons in this tellurium. Okay, now number of electrons, so this tellurium is an atom, so number of protons and number of electrons will be equal. That's why there is no overall charge, so number of electrons will be 52. Okay, part B, identify the subshell in an atom of tellurium that contains electrons with the lowest energy level. Okay, so the lowest energy level is always 1s. Okay, now part C, construct an equation to represent the first ionization energy of tellurium. So ionization energy is actually the energy change when 1 mole of gaseous atom change into 1 mole of gaseous ion. So when this gaseous tellurium changes into 1 mole of gaseous ion, this is the first ionization in tellurium. Okay. Now part D, the radius of tellurium ions decrease after each successive ionization. There are two factors that are responsible for the increase in the first 6 ionization energies of tellurium. So let's say you have 52 protons and you have 52 electrons. Now after first ionization energy, you will have 51 electrons, but this proton number is constant, so there will be more attraction of protons, or you can say nucleus, to these electrons, and there will also be less shielding factor. And then after second ionization energy, you will have a 50 electrons, then 49, and so on. So number of electrons are decreasing, but this number of protons, they are the same, so they will attract electrons more to themselves. Okay, that's why the ionization energy after each successive ionization energy will increase. That's why, so you will write that the nuclear attraction will increase because the nuclear attraction will increase after each successive ionization. Each successive ionization, because there is decrease in shielding factor, because decreased shielding factor or number of electrons are decreased shielding factor. Okay, so now moving towards part 2, sketch a graph in figure 1.1 to show the trend in this first 7 ionization energies of tellurium. So the electronic configuration of this tellurium is given to you. It's actually a krypton. Then you have a 4d 4d10. Then you have 5s2 5p2. Okay, this sorry, 5p4. So now their first four electrons will be removed from this 5p4 subshell. Okay, so let's say this is the first ionization energy. Then you have second, third, and fourth. Then the fifth electron will be removed from 5s orbital, and this s orbital is lower orbital or in lower energy than this p orbital. So this there will be a higher, uh, you can say higher change in the fifth ionization energy, but not as much higher. Okay, because the shell is not changed. Shell is the same, which is fifth shell. Okay, but there will be little more energy required for the fifth ionization energy. Then you have sixth ionization energy like this, and then for the seventh ionization energy, the shell is changed, so there will be a big jump like this. Now you can draw the line, sorry, like this. So so this is your graph for the first seventh ionization energies of tellurium. Okay, now part E, tellurium reacts with fluorine at 150 degrees 150 degrees Celsius to form this tellurium Fx. The molecules of Fx are octahedral. So it means that this X is equals to 6, because when this F this is 6, then it would be F6, and that it would have a structure of geometry of octahedral with the bond angles of 90 degrees. Explain why this FTEFX is an octahedral with the bond angles of 90 degrees. So you can say that there are 6 bonds of electrons, or you can say X is equals to 6. Okay, so X is equals to 6 because, sorry, X is equals to 6. So it has, uh, or you can also write that X is 6 electrons. So bonding pairs, bonding pairs repel equally. Okay, that's why it has an octahedral geometry and the bond angle of 190 degrees. Sorry, because the bonds are of same electronegativity. There are 6 F fluorines, and they will each repel equally. Okay, now part F. Tellurium F6 reacts with water to form tellurium hydroxide and HF. The oxidation state of tellurium does not change during this reaction. Construct an equation for the reaction of TeF6 with water. So this is the tellurium F. This is 6. Okay, so I'm writing it 6. You can write this. Okay, TeF6 plus water. So it forms tellurium hydroxide, and it told you that the oxidation state of tellurium does not change. So there, the oxidation state of tellurium in this TeF6 is plus 6. Okay, so here it will also have a oxidation state of plus 6. Then you have HF. So balance the equation, and this is your final equation. Okay, Now, name the type of reaction that occurs when tellurium reacts. This compound of tellurium reacts with water. So it is a hydrolysis reaction. Okay, the ionic compounds are soluble in water, and these covalent compounds are hydrolyzed in water. Okay, so you have to remember this. Now, question number two: a neutralization reaction occurs when sodium hydroxide is added to sulfuric acid. Okay, part A. Define the enthalpy change of neutralization. So it is the energy change when 1 mole of water is formed from when an acid and base reacts. Okay, so enthalpy change when 1 mole of water is formed from an aqueous from an acid and an alkali, or you can say base and an alkali. Okay, alkali or base, you can write both of these. Now, an experiment is carried out to calculate the enthalpy change of neutralization for the reaction between sodium hydroxide and sulfuric acid. So 100 cm cube of 1 mole per dm cube of sodium hydroxide is added to 75 cm cube of 1 mole per dm cube of sulfuric acid in a polystyrene cup and stirred. The results from the experiment are shown in table 2.1. Use the equation 1 to calculate the amount in mole of sulfuric acid that is neutralized in this experiment. So you have to calculate the amount moles. Okay, so you have to see which one of them is the which one of them is in excess. Okay, whether it is sodium hydroxide which is in excess or sulfuric acid. So if you see here, this is your equation 1. So let's say the concentration is same of both. There is 1 mole per dm cube and 1 mole per dm. So if you say that there are 100 sodium 100 cm cube of sodium hydroxide, okay, 100 cm cube. So how much sulfuric acid is needed? So from the ratio you can see 50 cm cube of sulfuric acid is required, but there is 75 cm cube of sulfuric acid present. So it means the sulfuric acid is in excess. Okay, so you will not find the moles of sulfuric acid that react from this volume. You will find the first you will find the moles of sodium hydroxide, then you will compare the moles which are needed by ratio. Okay, so the moles of NaOH is equals to 1 multiplied by 100 divided by 1000, so it's 0.1 moles, and by ratio you can see that there is 2:1, so N of sulfuric acid is 0.05. That is the moles that are neutralized in the experiment. Okay, 0.05. And if you see, if you have calculated the moles from these volume and concentration of sulfuric acid, you will get 75 divided by 1000 into 1, 0.075. Okay, but that's not the correct answer. Okay, now part 2, they calculate the neutralization enthalpy change of neutralization using the result in table 2.1. Okay, 2.1. Okay, include units in your answer. Assume that the specific heat capacity of the final solution is this, and 1 km cube of final solution has a mass of 1 gram. There is no heat loss to surrounding. Full dissociation of sulfuric acid occurs. The experiment takes place at constant pressure. So you will use the equation Q is equals to MC del theta. That theta is the change in temperature. Okay, so the change in temperature is actually 7.8. You can see from this, the initial temperature was 20 and the final temperature, or you can say temperature, yeah, the maximum temperature was 27.5. Okay, so now you know the temperature change, and you are also given the value of C, which is specific heat capacity, and its value is 4.18. Now the mass will be the overall mass. Okay, you will the total volume, the total volume is actually 100 plus 75, it's 175. Okay, so now let's calculate 175 into 4.18 into 7.8. Okay, so it's going to be negative. You can write it negative. Okay, or yes, just for the forget about negative sign for now. So 5705.7. Okay, so that's your energy. Now you have to calculate the enthalpy change of neutralization, so you will divide it by moles. Okay, but the moles of the water, you will uh, calculate the moles of water. So from the ratio, if you see, the moles of NaOH is 0.1. Okay, so 0.1 mole of NaOH will form 0.1 mole of water. Okay, so now this this energy is in joule, so you can convert it into kilojoules. So 57, so it will be 5.705 kilojoules divided by 0.1, so you will get 57.1 kilojoules per mole. So that's your enthalpy change of neutralization, but it would be negative because the enthalpy change of neutralization is exothermic. Neutralization is an exothermic. Okay, so negative of 57.1 kilojoules per mole. Okay, now moving towards part C. Complete the equation for the reaction that occurs when a solution of barium hydroxide is added to the aqueous sulfuric acid. Include state symbols. Okay. So when this sulfuric acid reacts with barium sulfate, barium hydroxide, sorry. So barium hydroxide is an alkali, or you can say base. So it will react to form barium sulfate, which is insoluble. So it would be sulf uh, solid in form, and then you will have water. Okay, so uh, this water will have, there will be 2 moles of water. You have to balance the equation as well. So the overall equation is balanced. There will be 1. So this is your balanced equation. You have to also include the state symbols. Now suggest why the enthalpy change of neutralization cannot be determined using the addition of dilute sulfuric acid to aqueous barium hydroxide, because this there is a precipitate formed, and this precipitate will also have an energy change. Okay, so precipitation precipitation station of barium sulfate also involves energy change. That's why you cannot determine the enthalpy change of neutralization. Okay, now moving towards question number 3. Chlorine is very reactive element. Chlorine is very reactive element. Okay, So chlorine reacts with silicon to form silicon 4 chloride. Describe the appearance of silicon 4 chloride at room temperature and pressure, and state its structure and bonding. So it's actually SiCl4, and it is liquid at room temperature and pressure, and it has a structure, simple structure and covalent bonding. So it's simple covalent structure and bonding. Okay. Now part B, the samples of magnesium chloride and phosphorus 5 chloride are added to separate beakers of cold water. Now you have to remember this PCl5 is the covalent compound and magnesium chloride is ionic compound, so they will react with water differently. Okay. Now complete table 3.1, ignore the temperature changes when considering the observations for these reactions. Now appearance at room temperature. So both of them are solid at room temperature. Okay, solid, and this is also solid, or you can write it as crystals. Okay. Now one similarity in observation in addition to water. So when this magnesium chloride is added to water, it will form magnesium 2 plus ions plus Cl minus ions. So the colorless solution will form. Okay, and this solid will dissolve. And when PCl5 will react with water, it will form. Um, it will be hydrolyzed in water, so it will form phosphoric acid plus HCl. Okay, so this will also form a colorless solution. Okay, so colorless solution. So this is the observation that colorless solution is made in both of these solutions. No precipitate in both of these solutions. Colorless solution is formed. Okay. Now one difference in the observation. So if you see that this magnesium chloride, it has actually a pH of 6.5 to 7. You have to remember this pH. Actually, we write this pH of magnesium chloride as 6.5. NaCl, sodium chloride, has a pH of 7. Okay, so this chloride has a pH of 6.5. So let's ask you in the next part. Okay, so the pH of final solution will be 6.5 of this magnesium chloride, and the pH of this will be, these are both acids and strong acids, so the pH will be 1 to 2. Okay. Now one difference in observation on addition to cold water. So if you see, there will be no misty fumes in this magnesium chloride, but there will be misty fumes of HCl in this uh, the phosphorus 5 chloride. Okay, so misty fumes will be observed and no fumes. Okay. Now part C, state the reagents and conditions required for the formation of sodium chlorate 5. It has a formula of NaClO3 from chlorine. So if you react sodium hydroxide, hot sodium hydroxide, with this chlorine, it will form sodium chlorate 5. Okay, so hot aqueous sodium hydroxide. Okay, this is your reagent and conditions. Now part 2, explain why the reaction in C1 is described as disproportionation reaction. So it is a disproportionation reaction because when sodium hydroxide reacts with chlorine, when this is hot sodium hydroxide, so it forms NaCl plus NaClO3 plus water. So if you see that the chlorine is both oxidized and reduced, oxidation state of chlorine here is 0, and in sodium chloride it has an oxidation state of -1, so it is reduced. And in this sodium chloride 5, this chlorine has an oxidation state of +5, so here it is oxidized. So if in a species is oxidized and reduced. This the reaction is called disproportionation reaction. Okay, so your answer should refer to relevant species and their oxidation states. So the chlorine, you can say that the oxidation oxidation state of chlorine increases from 0 to +5 and decrease from 0 to -1. Okay, -1. So that's why this reaction is called disproportionation reaction. Okay. Part D. Chlorine reacts with methane in a series of reactions to produce chloroalkanes. Set the conditions required for chlorine to react with methane. Okay, so UV light is required. Okay, UV light or ultraviolet light. Now, part 2. One of the products of the reaction is CH2Cl2, which reacts further to produce CHCl3. Okay. Complete table 3.2 to show the details of the mechanism that forms when CHCl3 uh, forms CL, CHCl3 from CH2Cl2. Okay. So the initiation reaction, the initiation step is the form of chlorine free radical. Okay, so these are the chlorine radicals, and this this is the initiation reaction. Now the propagation step. This is a very careful step. So how this first you can see that this there is one replacement of hydrogen. Okay, between this CH2Cl and CHCl3. Okay, so one hydrogen will be removed in this propagation step. So it will form CHCl2 and plus HCl. Okay, in propagation step, the reactants and products, both of them have this radical. Okay, and in initiation reaction, only products have these can say radicals, and in termination reaction, both of the reagents will have these radicals, and product will not have a radical. Okay, so now this CHCl2 will react with chlorine radical. The one radical, chlorine radical, that form react in this part, and the second, the chlorine radical, will react in this part to form CHCl3. I hope it's clear. Okay. If you have this CH2Cl plus chlorine free radical will also form, uh, you can say, this CH2Cl plus chlorine. Okay, this would have also formed, but you cannot write this equation because that's not included in the mechanism of formation of this CHCl3. Okay, now part E. When CHCl3 and HF are used to form CHClF2 in a substitution reaction, construct an equation. Okay, CHCl3 plus HF, they both react to form CHClF2 plus, it will the species which are removed is one Cl, HCl. So there's now balance the equation. So you will get uh, like this. So this is your balanced equation. Now, part F. X is a product of substitution reaction that occurs when CHClF2 reacts with bromine. Okay. Now there is only one naturally occurring isotope of fluorine. Okay. So fluorine has only one isotope. The mass spectrum of X shows molecular ion peaks at 164, 166, and 168. Now, complete table 3.1 to show all the molecular ion peaks responsible for each peak. Okay, so this 161, 168 peak, sorry, is given to you, which is CF and CF, so chlorine 37 and bromine 81. So if it is a peak of at 168, and it told you that this fluorine has only one naturally occurring isotope, so we will only deal with these isotopes of chlorine and isotopes of bromine. And the chlorine has two isotopes, chlorine 35 and chlorine 37. And this Br, bromine, has two isotopes as well, bromine 81 and bromine 79. Okay, so this you are at 168. The peak is due to chlorine 37 and chlorine 81, bromine 81, sorry. So the peak at 66 could be due to CF2 and chlorine 35, and Br 81. Okay, bromine 81 plus, and it could also be due to CF2, Cl 37, and Br 79. Okay, so these are both possibilities for these peak at 166. Now for the 164, both of them will be these two, 35 and 79. So CF2, chlorine 35, and Br 79. So that's how you have to draw these formula of molecular ions. Now moving towards question number 4. V is a colorless liquid. V reacts with an axis of LiLH4 to form W. Draw the structure of W in the box. So W will actually reduce this carboxylic group to alcohol. So 1, 2, 3, 4. 1, 2, 4. So this alkene group will be unchanged. Only this carboxylic group will change into alcohols. Identify the role of LiLH4 in this reaction. So it's reducing agent. Its role is a reducing agent. Now part B. V reacts to form Z in a single reaction as shown in figure 4.2. Okay, so you can see that this V, in V, this double bond is changed into two alcohol groups. So you know that when you react alkenes with cold KMnO4, these two hydroxides are attached. This is called the mild oxidation. So suggest the reagents and conditions needed to form Z from V. So it's actually the cold dilute aqueous KMnO4. Okay, these are your reagents and conditions. Deduce the empirical formula of Z. So 1, 2, 3, 4. So C4, and then you have H 1, 2, 3, 4, 5, 6, 7. 2, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8 hydrogens, and you have 1, 2, 3, 4, 4 oxygens. So the empirical formula is going to be CH2O. CH2O. Now moving towards next part, complete table 4.1 to show number of sp2 and sp3 hybridized carbons atoms that are present in a molecule of V. In V, you can see that the one with the carbon atom which forms four bonds has sp3 hybridization, and one that forms three bonds has sp2 hybridization. So there is only one carbon which is forming four bonds, so there is only one sp3 hybridized carbon, and the others have the double bonds, so three of them will be sp2. So 3 and 1. Okay, three of the carbons are sp2 hybridized and one is sp3 hybridized. Now moving towards question number C, part C, sorry. Q contains the elements carbon, hydrogen, and oxygen only. It is a saturated molecule with no branching in its carbon backbone. So saturated means there is no double bond present. Okay, carbon carbon double bond. Now Q contains only one functional group. Okay, the relative molecular mass of Q is also given to you, which is at 8. Now no effervescence is seen when sodium carbonate is added to Q, so it means no carboxylic group. Okay, now effervescence is seen when sodium is added to Q, so it means there is an alcohol, and Q reacts with alkaline iodine I2 to form this yellow precipitate. So it means this methyl group is attached to the carbon which has alcohol attached. Okay, so now you know some of the information. From this information you can deduce the structure of this Q, that there is only one functional group which is alcohol. So alcohol is present, and the alcohol will be the alcohol has a methyl group attached. Okay, so now the molecular mass is also given to you. So if you see that, if I draw C5 H7 H11, sorry, 11 OH. So if you calculate this MR of this pentanol, so 5 carbons, so 60 plus 12 plus 16, so you will get the MR of 88. Okay, so it means this is pentanol. Okay, so now let's draw its structure. It's actually going to be like this: 1 2 3 4 5, and OH is attached on this second carbon. Okay, so this is your structure of Q. Now moving towards next question, last question, question number 5. Molecule M is present in petrol, a fuel used in car. Okay, M is a saturated non-cyclic hydrocarbon. Okay, M contains 8 carbon atoms. Okay, so saturated means it has no double bond and no cyclic hydrocarbon, and it has 8 carbon atoms. So it means it is a octanone, octane. Sorry, octane only. So construct an equation for the complete combustion of M. So C8H18, when it reacts with oxygen, it will form carbon dioxide and water. And there are 8 carbons, and how many hydrogens? 9. And you will also balance these hydrogen atoms, so oxygen atoms. Sorry. So you will get 25 divided by 2. Okay, so now describe how the composition of products differ when incomplete combustion of M occurs. So there will be less so you can write there when incomplete combustion occurs, so carbon monoxide, carbon, and unburned hydrocarbons will also form. Okay, so carbon, carbon monoxide, and unburned hydrocarbons will form. So less composition of carbon dioxide. Okay. Now, part B. When petrol is burned in an internal combustion engine, the oxides of nitrogen are released into atmosphere. Okay. The oxides of nitrogen are responsible for the formation of acid rain, suggest the conditions required for the production of oxides of nitrogen during the combustion of M in an internal combustion engine. Okay. Use an appropriate equation in your answer. So the conditions required for the oxides of nitrogen. There are many oxides of nitrogen, uh, and how they form. They actually the nitrogen and oxygen from air react at high temperature and pressure in this internal combustion engine. Okay, so you can say that this nitrogen and oxygen from air react at high temperature high temperature and high pressure to form oxides of nitrogen. And there are many oxides of nitrogen. Okay, but you have to write an equation. So let's say nitrogen and oxygen will react together to form nitrogen dioxide. This is also one of the equations. Okay, one of the oxides of nitrogen. So balance the equation. This is your final equation. Okay, so now moving towards part 2. Describe how the acid rain is formed in the atmosphere in the presence of oxides of nitrogen and sulfur dioxide. Identify the role of oxides of nitrogen in this process. Include all relevant equations. Okay. So this role of nitrogen dioxide. So this nitrogen dioxide is role of the catalyst. It uh, actually oxidizes this sulfur dioxide into this sulfur trioxide. Okay, so this nitrogen dioxide is the catalyst. Okay, so now you have identified the role of nitrogen dioxide. So now you have to include the relevant equations to show how acid rain is formed. So this nitrogen dioxide actually reacts with sulfur dioxide to form sulfur trioxide and nitrogen monoxide. Then this nitrogen monoxide reacts with oxygen in the air to form nitrogen dioxide. So in the end, nitrogen dioxide is unchanged, so it is a catalyst, and this catalyzes the oxidation of sulfur dioxide to sulfur trioxide. Okay, so then this sulfur trioxide reacts with water. Sulfur trioxide reacts with rain or moist with water water in atmosphere, or you can say water vapors, to form sulfuric acid. So that's how this acid rain is formed, to form H2SO4. Or you can also write equation for this reaction, which is sulfur trioxide reacts with water to form sulfuric acid. Okay, you have learned this equation in the contact process as well. Okay, now instead one other type of air pollution that is caused by the production of this oxides of nitrogen in an internal combustion engine. So it also forms a photochemical smoke, which is called PAN, when this oxides of nitrogen reacts with unburnt hydrocarbons. So it forms a photochemical smoke. Photochemical smoke. Now moving towards next part, part C, biodiesel tea. This is your biodiesel tea is fuel made from vegetable oil R. Okay, this is R. Figure 5.1 shows the production of tea from R in a two-step process. Okay. In step 1, all three ester groups in R reacts. Suggest a suitable reagent and conditions for the step 1. So in step 1, these ester groups, all three ester groups are broken to carboxylic acid, and the other you would also know that what other compound will form, the alcohol will form. Okay. So to change ester into to hydrolyze these esters, what is the reagent we use? We use an acid. Okay, heat and an acid. So heat, uh, you can write any acid. So dilute sulfuric acid and heat. That's how this ester group will hydrolyze. Okay, all three groups in R react. Suggest a suitable reagents and conditions. So now draw the structural formula of J in the box. So there are this molecule is same 1, 2, 3. So the structure of J is actually going to be like this. One, let's redraw. 1, 2, 3. Okay, 1, 2, 3. So there will be an alcohol attached, OH and OH. Okay, so this is the structure of J. These ester groups will hydrolyze to alcohols and carboxylic acids. Okay, then in step 2, the G plus concentrated sulfuric acid react with this L to form this T. Name the type of reaction that occurs in reaction step 2. So it's actually the condensation reaction. The formation of ester is actually the condensation reaction. Okay, condensation reaction. Now name the organic reagent G used in step 2. So you can determine G from this T. You can see that this L has OH group. So in ester you can see that this methyl, there is only one carbon in this alcohol, so methanol. So the organic reagent G is actually the methanol. Okay, you can identify this from the structure of T. You can see that there is an alcohol, and this alcohol is changed into ester group, and then you have an alcohol part of alcohol. So which alcohol is used? It is actually the methanol. Now L is called decanoic acid. Okay, use the systematic nomenclature to deduce the name of T. So the T, you have alcohol, methanol, and this carboxylic acid, which is decanoic acid. So the name of this ester would be methyl decanate. In the naming, we uh, name this alcohol group first. So methyl, because there is a methanol, so methyl decanoic acid, decanoate, 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 decanoate. Okay, so that's the systematic name of this tea. So that's all for the day. This paper is done. So if you have any queries in this paper, you can ask me in the comments. Thanks for watching, and do subscribe the channel, and thank you.